Hey, let's take a look at a real-world application where you can see lines in the coordinate plane unfolding, stretching out all over to help us solve real-world questions. So I'm considering one of two health plans, and I've got to figure out which one I want. Let me tell you about them. In fact, I have a little bit of a table here to show it to you. There's Plan A, there's Plan B. Plan A requires me to pay an initial enrollment fee of $100 and then a monthly fee of $40. Sounds pretty good. Whereas Plan B has no enrollment fee, but I pay $60 per month. And the question is, how many months would I have to sort of go through to actually have either of these plans actually cost me the same amount of money? So what's the break-even point when, in fact, will I have paid out the same to Plan A as I did for Plan B? All right. Well, we can actually think about this by setting up a model in terms of lines. Then we can actually solve them either algebraically or geometrically. So let's do both. So first of all, let's consider the actual issue here. So the first issue is, how much would I be paying per month with Plan A? Let's suppose that X represents the number of months that I'm in the program for. Well, if that's the number of months, then what do I pay? Well, I pay $40 per month. That's 40 times X. But don't forget, I have to pay that one-time fee of $100. So for Plan A, I see Y, the amount I pay, is going to equal 40X, that's my monthly fee for X months, plus that one-time $100 enrollment fee. So that's for A. What about for Plan B? Well, Plan B, how much would it cost? If X represents the months again, there's no enrollment fee, but I pay $60 per month. So 60 multiplied by the number of months, but there's no enrollment fee, so that's it. So these two equations represent the two possibilities, A and B. Well, let's solve them. Well, the way we can solve them, if we want to solve them algebraically, is just we can take these two equations and subtract them. So let's take the A and subtract the B and see what we get. When we subtract, Y minus Y is 0. 40X minus 60X is negative 20X. And then 100 minus 0 is plus 100. I can now subtract, I can add 20 to both sides to undo that subtraction. And when I do that, I see 20x equals, and negative 20x plus 20x is just 0, so equals 100. And now I can divide both sides by 20, and I see x equals 5. The units here, by the way, are months. So 5 months is the break-even point. That means that if I were to enroll in Plan A, 5 months later, the amount I would actually spend would be equal to the amount I would spend if I were going into Plan B. So there's the answer, and we can see that algebraically. Let's now look at it visually. So geometrically, I could actually graph, if I wanted to, the months on the x-axis and the cost in the y-axis. And now I have two straight lines. Let's graph the lines. So the first one is y equals 40x plus 100. So that's a y-intercept of 100. And the slope is 40 over 1. So I go 1 over 40 up, 1 over 40 up. And what would that mean in terms of 5? If I go 5 over, how high do I have to go? Well, then that's going to be 200 up. So I go 200 up, 1, 2, 5 over. I get to here. Use my straight line. And I can graph the purple Plan A. So that's Plan A. Now what about Plan B? Plan B is y equals 60x. Well, there's a y-intercept of 0, and the slope is 60. And so that means that I go 60 up and 1 over, 60 up and 1 over, and so forth. So when I graph this, gotta do it carefully here. The lines get pretty close together for a little bit. So this represents Plan B, And you can look at these two and you can ask, where do they actually intersect? And you can see they intersect right here. And what point is that? That's 5 months, which is what we found. But the graph actually tells us more, because not only do we see that 5 months is the break-even point, but I actually see how much I would be spending for 5 months. I can read over and see 300. This also shows me a lot of other things. If I'm only going to enroll in the program for a few months, what's the better deal? The answer is B, because the line B is actually below the line A. So I actually save money. But after the break-even point, then all of a sudden B becomes more expensive, and I was better off with A. So in fact, the visualization tells us all sorts of things about the dynamic question, not just one moment of information, but in fact a whole sea of information, and that's the power of looking at things geometrically. Anyway, enjoy thinking about lines in the plane, and I'll see you soon.